Hello, am I audible now? Yes, sorry. So I missed this one. So am I audible now? Am I audible now? Tell me. Okay, fine. Sorry, so I didn't see your messages. Okay, right. So the next one, the resistance of a wire at 0 degrees Celsius. Yeah, this is also similar kind of problem. You see this thing here, the variation of resistance, which is given as what? Tell me now. So this is that is R, which is equal to R naught into 1 plus alpha T, right? This is the resistance variation with the temperature. Now you see this thing, what they given now. So at they given three different temperatures. Now at T is equal to 0 degrees. They given how much the resistance value given, which is equal to 10 ohms. Okay, that means this is nothing but R naught given. Now at T is equal to 100 degrees Celsius and they given the resistance value given as what will be now 10.2 given. Now what will be the temperature when the resistance is equal to 10.95 ohms? Now we'll substitute the values in the formula. So now which will be equal to, yes, now this is 10.2, which is equal R naught is at 10 into 1 plus alpha T, T value 100. Next, so this is 10.95, which is equal to R naught into 1 plus alpha into T. Here also we should get the T value only. Exactly same as earlier. Now try this thing. If I take the ratio between these two, 10.95 by 10.2, and which is equal to what will be now 1 plus 100 alpha by 1 plus alpha into T. Now you can simplify this one. How much will come? So this is 10.95 by 10.2 now. So this value come to be a 1.07, which is equal to 1 plus 100 alpha by 1 plus alpha T. Alpha value given? No, not given. Alpha value not given now. Oh. So then what we can do here, we need to use this relation we have to use to get the alpha value separately then. Okay, then what we should do here, from this, if I call this is equation 1, from equation 1 we can get this alpha value. So here so this is what we have. If I divide now here 10.2 by 10, which is equal to 1 plus 100 alpha. Now we can substitute this value here. Now so this is for subtract, now this is 100 alpha, which is equal to 10.2 by 10 minus 1. So then it is 100 alpha equal to 0.2 by 10. So that means, so this is alpha, which is equal to, yes, 2 into 10 power minus 4. Okay. Now once you got it now here, we'll use this second equation to get the T value. This is 10.95, which is equal to 10 into 1 plus, we have alpha value 2 into 10 power minus 4 into t. So this is 1 plus 2 into 10 power minus 4 into t, and which is equal to 1.095. That means now t value is what will be now 0.095 by 2 into 10 power minus 4. So the t value will come to be a. So how much now here? 0.0475. 0.0475 into 10 power plus 4. That means t value 475. This is in degrees, but they ask in a Kelvin scale now. So add 273, which will be equal to 475 plus 273. Alpha is not linear coefficient here. Alpha is called as a temperature coefficient of resistance. Alpha is a temperature coefficient of resistance. 475 plus 273. So this value how much now here? 748 Kelvin. Alpha is the temperature coefficient of resistance. Next, see the next one. A wire of resistance capital R and radius small r is stretched till its radius becomes R by 2. If new resistance of the stretched wire is X into R, the value of X is. Now see what they given now here. Radius is given now. The resistance of any material, resistance is given as what? Basically rho L by A. The wire is stretched until its radius becomes what will be now? R by 2. Now what I am doing is multiplying and dividing with A. Now this resistance R will become rho into area into length is called as a volume by A square. So then it will becomes R equal to, that is rho into V. What the V is the volume. Volume remains constant and A is pi R square ka whole square. So this is rho is a constant, V also constant. So the resistance proportional to what tell me now? 1 by R power 4 na. Small r is a radius. Okay. Now from this we can get the relation now. That is R1 by R2, which is equal to R2 by R1 ka whole power 4. That is R by R2, which is equal to nu, that is R by 2 by R power 4. So this is R by R2, which is equal to 1 by 2 power 4, means 16. So that is R2 value equal to 16 into R. This is the new resistance of the same wire. Okay. Here the volume, rho is the resistivity and V is the volume remains constant. And remember, if the wire is stretched or elongated or compressed, in these cases volume remains constant. Volume remains constant. Keep in mind. Next. The current in an inductor is given as like this. They ask you to find the amount of electric charge that flows through a section of conductor from 1 to 2 seconds. Right, the current I given as what, tell me now? 3t square plus 4t cube. And we need to find what, tell me now here? Charge we need to get. How will we get the charge from? Current you tell me now here? Integrations. Integral. From way to way we need to do here. So from 1 to 2 seconds. So that is t is equal to 1 to t is equal to 2 seconds. And that is 3t square plus 4t cube into dt. Now integrate now here, simplify. So it will come to be what will be now integral. So integration will come to be 3 into t cube by 3 plus 4 into t power 4 by 4. Limits 1 to 2. 4, 4 cancel, 3, 3 cancel. So q is equal to how much now here? So this is 2 cube minus 1 plus 2 power 4 minus 1. So will come to be a 8 minus 1 is 7 plus 2 cube 16 minus 1 15. So which will be equal to how much now? 22 coulombs. Next. An electric toaster has resistance of 60 ohms at room temperature. The toaster is connected to a at so they given this as at what temperature now here? At temperature T is equal to 27 degrees Celsius. The resistance is given as how much now? 60 ohms. Now when it is connected to a source of supply 220, the current flowing is given. So from this we can get the resistance now. R is equal to V by I. So V value how much now? This is 220 by 2.75. So how much this value will come, tell me? 220 by 2.75. So this value resistance is 80 ohms. Okay. Now, so they are saying at T, we don't know what is the temperature. At this location, resistance is given as what, tell me now? 80 given. They given alpha also. They ask him to find the temperature. So you can substitute the relations now. R is equal to R naught into 1 plus alpha into T. So that is R. We can substitute the values now here. One resistance is 60 equal to, that is R naught into 1 plus alpha will substitute into 27. Next one is 80 equal to R naught into 1 plus alpha into T. Now if we have taken a ratio between these two, so we'll come it as what, tell me now here? 80 by 60, which is equal to 1 plus alpha T. by 1 plus 27 alpha. Cancellations now here. 0 cancel now. This is 4s and this is 3s. So it will becomes what, tell me now here, 4 plus and 4 into 27 alpha, which is equal to 3 plus 3 alpha into t. Alpha value given now. So then this value 3, 1 will get cancelled 1. So we can write it as this is 4 into 27 into alpha value 2 into 10 power minus 4 equal to 3 into 2 into 10 power minus 4 into t. So how much will come here? 8. 8 into 27. 27 into 8. So 216. This is 0.0216, which is equal to 6 into 10 power minus 4 into t. This is 1.0216 by 6 into 10 power minus 4, which is equal to t. Tell me now how much this is. 1.0216 by 6 into 10 power minus 4 will come to be this t value 17. If you simplify it now here, we are getting it as t value how much now here? 1702.6 degrees Celsius. And we can choose the nearest option for it. So this could be the nearest option now. We did some approximations. Next one. The electric current through a wire varies with the time as I given. I is equal to I naught means 20 plus beta value 3 into t. The amount of electric charge is, so that is Q is equal to integral from 0 to 20. 0 to 20. Now this is I into dt now. So this is Q value in integral 0 to 20 seconds. I value given as 20 plus 3t into dt. So then this value come to be at 20 into t plus 3t square by 2. Limits 0 to 20. Now you can simplify this thing here. So this is 20 into 20 minus 0 plus 3 by 2 into 20 square means 400. So this is Q is equal to, this is 400 plus 2 200s. So this is 600 now. So how much the charge you can tell me now here? 1000 coulombs. Next, a wire of resistance 160 is melted and drawn in wire of 1/4 of its length. 1/4 of its length. That means, so here initial length, if I call L1 is equal to L, now this L2 is what, tell me now? 1/4 means L by 4. Okay. So the resistance, initial resistance is given as a 160. 160 ohms. Now they are asking to find the final resistance. Right. Now you can tell me now here the resistance of a wire which is given as rho L by A. We are multiplying and dividing with A here. So that is R is equal to rho into V. No, here we L given now. So I will do it as what, tell me now, multiply and divide with L से multiply करो. L से multiply. Length is given now here. Previously radius given. Now I can make it as R equal to rho L square by volume. So here rho is a resistivity and V is the volume. Resistivity and volume remains constant only. So that means R proportional to L square. Then we can say R1 by R2, which is equal to L1 by L2 whole square. So let's simplify it now here. That is 160 by R2, which is equal to L by, that is L by 4 whole square. That is 160 by R2, which is equal to 4 square. That is 160 by 16 equal to R2. Then what is this R2 value? Tell me now here, 10. Okay. Next. The current flowing through a conductor connected across a source is 2 amperes and 1.2 amperes at 0 degrees and 100 degrees respectively. The current through the conductor at 50 degrees is. It is connected to a fixed source and basically the resistance which is given as what, tell me, that is given as V by I. And then from this I is equal to what, tell me now, V by R. Okay. Now, so at 0 degrees we have a current is given, that is R is R naught. Okay. Next, so we can write as what, tell me now, I1 they given at T is equal to how much now, 0 degrees Celsius. We have this current I1. How much this current is at 2 amperes is given now. Next, and at T is equal to 100 degrees Celsius, they given the current. How much this current is given? 1.2 amperes. They ask him to find when T is equal to 50 degrees Celsius. They ask him to find this current. They ask him to find. Okay. So that is because of resistance only will changes. Here, as the temperature changes, resistance changes, then we have a current will changes. So now, initially, this is what I can write now here. I can use a relation now here, R. R is equal to what, tell me now, basically that is R naught into 1 plus alpha T. Here R naught is given. So this is R2 I can write as what, element of V by I2 I can write now, which is equal to, that is V by I naught, V by I1 into what, element of 1 plus alpha into T. So V will get cancelled. That is 1 by 1.2, which is equal to 1 by 2 into 1 plus 100 alpha. Right. So if you bring here, so it will be a 2. I can say 20 by 12 minus 1 equal to 100 alpha. That means 100 alpha will come to be what, tell me now, 8 by 12. So 4 2's, 4 3's. That means alpha value how much now here? 2 by 3 into 10 power minus 2. Check this, alpha got the same thing. Now this alpha I will use in the other equation. So what I can do here, V by I3, which is equal to V by I1 into 1 plus alpha into temperature T3, that is 50. I3, so I can say 1 by I3 equal to 1 by I1 into 1 plus alpha 2 by 3 into 10 power minus 3, minus 2 only, minus 2 into 50. So we'll come it as 1 by I3, which is equal to 1 by 2 into 1 plus 2 into 50, 100 will get cancelled, 1 by 3. So this is 1 by I3, and which will come to be a what, tell me now, 1 by 2 into 4 by 3 na, 4 by 3. Then that means 1 I2 value how much now, which will be equal to 2's. So 3 by 2, that is 1.5. This is amperes na. They are asking in the milliamperes. So that means how we can write now, I2 is a milliamperes 150. So this value, which will be equal to what, tell me now here. So amperes, we should write in the milliamperes na. So this is 1.5 into 10 cube. Milliamperes means 10 power minus 3 we can write now. Now it is milliamperes. So this value, how much we can say now here? Yes, now 150 into 10 power. This is amperes. Now we can write this as, one more zero will place me. One more zero into 10 power minus 3. This is amperes. They ask the milli means I2, which we can say this is 1500 milliamperes. So this means here in this blank we need to fill it up 15. Next one. The length of a metallic wire is increased by 4% and its area of cross section reduced by 4%. Length increased by 20%. So that means L2, if I assume this as, let us say L1 equal to 100, then L2 is what will be now increased by 20%. It will becomes 120, I can say. Okay, so then, and what about this area they are saying now here? Area A1, which is also 100 if I consider, it is decreased by 4%, means what will be now 96 now? Now, what is the variation of resistance now here? R equal to, that is rho L by A. So we can write as what, tell me now here? L changes, area changes. So we can say R1, I can write it as R2 by R1, which will come to be a what, tell me now here. So this is A1 by A2 into L2 by L1. Then will come to be a R2 by R1. A1 means 100. A1 means 100. A2 means 96. L2 value 120 by L1 value 100. So we'll get cancelled. And this is 4. 430. 4 2's 4's. Again 2. 212. 215's. So we got it as R2 by R1. R2 by R1, which is equal to what we'll get now, 15 by 12. We need percentage of change na. So for that, what I am doing is R2 by R1 minus 1. I am doing subtraction both sides. 15 by 12 minus 1. Now it is R2 minus R1 by this is R1. So which will come to be what, tell me now here, 3 by 12. So 3 by 12 now. We are multiplying the 100 to get a percentage. Here also multiply the 100 now. Then this is called as delta R by R1 into 100. This is called as a percentage of change only now. So we'll come it as what, tell me now, 4 threes and 4 25. 3 cancel now, which will come to be how much now? 25%. Next, the charge flowing in a conductor changes with the time as given. Okay, the minimum value of current is, they are asking the current is minimum. So that means Q of t, charge given as what, tell me now, alpha t minus beta t square plus gamma tq, right? So we can get this current now. First, I is equal to dq by dt. So you can tell me now here alpha minus 2 beta into t plus 3 gamma into t square. This is the current. Now this is the function. They are asking the minimum value of a function. How to find the minimum value of any function? We'll differentiate and we'll equate it to 0 now. Same thing will proceed now. Now we are finding it as to get the maximum or minimum value of any function. We'll differentiate the function 0 minus 2 beta plus what, tell me now, 3, that is 6 gamma into t, and we'll equate it to 0. And from this we can get the t value. So how much the t value now here? That is 2 beta by 6 gamma. So that is t will come to be what, tell me now, beta by 3 gamma. Okay. Now we need to put the value in the current equation to get the minimum value. So this is I, which will be given as, we got it as alpha minus 2 beta t plus 3 gamma t square. So for minimum value, we can put the t value now. T is equal to given as beta by 3 gamma. So then how much will come here? Alpha minus 2 beta into t means beta by 3 gamma plus 3 gamma into t square, that is beta by 3 gamma whole square. Then simplify it now here. Alpha minus, okay, that is 2 beta square by 3 gamma plus 3 gamma into beta square by 9 gamma square. So this is gamma, gamma cancel 3 threes. So how much will come? That is alpha minus 2 beta square by 3 gamma plus what will be now, beta square by 3 gamma. So how much is I value, tell me now? This is alpha minus beta square by 3 gamma. Okay. Next. The resistance of a wire is 5 ohms. Its new resistance in ohms if it is stretched 5 times its original length. It is stretched how many times? 5 times they stretched. Now, so this means L2 is given as what element of 5 times of L1. So we have seen R is equal to rho L by A multiply and divide with L. So that means R will become rho into L square by volume. Rho and V constant. So that means I can write R proportional to L square na. R proportional to L square. So from this what I can say, tell me now, R1 by R2 which will be equal to L1 by L2 whole square. Then it is R1 5 and R2 we need to get, and L1 value L1, so L2 value 5 L1 ka whole square. So this what I will get now, 5 square. So this is R2 will come to be a 25 into 5, which will come to be a what will be now here 625 ohms. Okay, classes. Yeah, classes will continue. So this month will continue. This month will continue until completion of these topics we'll do. And next month I will tell you when I will start. Most probably June second week onwards again will start. If a copper wire is stretched to increase its length by 20%, the percentage increase in resistance of the wire is the percentage of increase in the resistance. Now, so stretched its length. So that means L1 if I call it as 100 and it is stretched by 20% means it will become 120 meters now. Now we can write as R. Stretching, whenever stretching is done, so that means volume constant, we can say R proportional to L square, isn't it? अभी ने देखा हमने. So from this we can write R2 by R1 which is equal to L2 by L1 का whole square. So that is R2 by R1 which is equal to L2 means 120 by 100. 120 by 100 whole square. Now you can tell me how much will come. This is R2 by R1 which is equal to, so 6 by 5. That means 36 by 25 now. Now I can say this as R2 by R1 minus 1 if I do both sides. 36 by 25 minus 1. Now it will becomes R2 minus R1 by R1 into 100, which will come to be a 36 minus 25 by 25 into 100. So this is nothing but we can say change in R only na, percentage of change in resistance, which is equal to, this is 9 na, so no 11. This is 11 by 25 into 100. So 25 fourths na, so which will come to be a 44%. Next. A 1 meter long wire is broken into two unequal parts. X and Y. Right, the X part of the wire is stretched into another wire W. Length of W is twice the length of X. Length of W is twice length of X, and the resistance of W is twice that of Y. Find the ratio of X and Y. Ratio of length of X and Y. So did you understand the problem here? I have this wire, a 1 meter wire, which is break into two parts, unequal parts they mentioned. If I call this is X wire and this is Y wire. Okay, right. Oh. Now, X part of the wire is stretched into another wire. X part of wire is stretched into another wire. So if I call this length is something L1, okay, and this length is L2. X wire is stretched into another wire. This is stretched into another wire W. Now this is W. Length of W is twice the length. So this is, if I call this as LW, okay, we'll call this as Lx and Ly, will consider Lx, Ly. Length of W they given as twice the length of X. So this is 2 times. That is 2 into Lx. So now, yeah, tell me now, and resistance of W twice that of Y, and Y is same. Yeah, you see this thing first of all, when the length is stretched like this, the resistance of W, it has to become what, tell me now? 4 times the resistance of X. Yes sir, now tell me. And this is one equation. And what else they given other condition? The resistance of W, that is resistance of W is twice the resistance of Y they given. Na? Resistance of W is equal to 4 times the resistance of X, which is equal to 2 into resistance of Y. So it is 2 into resistance formula is what, tell me now? Rho Lx by A na, which is equal to S2 cancel. This is rho Ly by A. A rho value same where we are talking. So means Lx by Ly, which will come to be a what L be now here? Lx by Ly, that is 1 by 2. Got it? 1 by 2. Next. A wire of resistance R1 is drawn out so that its length is increased by twice its original length. The ratio of new resistance to original resistance is, means what they given now here, this length L2 is given as what, L be now twice the L1. L2 given as twice the L1. So what about this is, as we have seen, the resistance proportional to L squared na. So from this we can write as R2 equal to 4 times the R1. They asked to find the new resistance by old resistance na. That's why it is 4 by 1. Okay. Oh. Next. The variation of applied potential and current flowing through given wire is shown in figure. The length of the wire is 31.4 centimeters. Okay. Diameter of the wire is given. The resistivity of the wire is given. Yeah, you can see now potential, voltage, and current is given slope. So, what is the slope of this line? You tell me now. Slope means what? Tell me now. Voltage by current only, na? And that is nothing but resistance. As we know, slope is nothing but tan theta only. And theta value 45 degrees is given. So that means indirectly they has mentioned it as how much the resistance they are saying here. The resistance equal to 1 ohm. Indirectly they given this information. Now they ask him to find the resistivity. Yeah, what is the resistance formula is, that is rho L by A. Yes, R is a resistance. Resistance is 1. We need to get the rho value. Rho is equal to, we can simply say A by L, we can write now. A value, they given diameter given. So diameter, so radius, that is 1.2. That is pi into R square, 1.2 into 10 power minus 2 whole square by length is what, tell me now here. So this I can write as, yeah, 3.14 into 10 power minus 2. Pi and 3.14 will get cancelled. Pi and 3.14. So then how much is value of rho, tell me now, which is equal to 1.2 into 1.2 into 10 power minus 4 by 10 power minus 1. So this rho value, which will be equal to 12, 1.44 into 10 power minus 3. But they are asking the centimeters, they are asking, na? So we should multiply with 100. So this rho value, this is the ohm into meters. 144 into 10 power minus 3, then it is ohm centimeters. Okay. So X value is how much now? 144. Next, resistance of the wire is measured as a 2 ohms and 3 ohms at 10 degrees and 30 degrees respectively. The temperature coefficient of resistance of the material is, alpha value we need to calculate. Yes, so resistance variation R is equal to R naught into 1 plus alpha T. So if you put now here 2, that is R naught into 1 plus alpha into T. T value temperature is 10. Next 3 is equal to R naught into 1 plus alpha temperature 30 alpha. So if I take the ratio now here 3 by 2, which is equal to 1 plus 30 alpha by 1 plus 10 alpha. Cross multiply and simplify now here. So it will come to be a, so this is 3 plus 30 alpha, which is equal to 2 plus 60 alpha. Now, which is 1 is equal to 30 alpha. Then alpha equal to 1 by 30 na. So I will come it as 0.033. Option A. Next one. The current density in a cylindrical wire of radius 4 mm. 4 mm is given as this much. The current through the outer portion of the wire is. So basically, so this is current. Current is given as what? Tell me now. Current density into area. Yes. Current equal to current density J into area. They ask him to find the current. Where they ask him to find the current, you tell me. This. Yes. Now you can see now here. Yes, this is R. Now they ask him to find the current. In which region they asking, you see. They asking the current only in the this this shaded part only we need. They ask. Only in this part only we need the current. And the remaining part is we can treat as like a simply some hole. Okay. In this region we need, so here in this region only we need now here. So that part of area we need to calculate. So that means what I can write now here. Total minus this R by 2 if I subtract now, this is what I'll know R by 2, and this whole part is what I'll know R. The whole part is R. So here total minus R by 2 if I remove remaining part, I will come now area. So this means I is equal to J value 4 into 10 power 6, and this area how much I required now, pi R square minus pi R by 2 whole square, that is R square by 4. Check this thing all of you. Then it will come to be a what, tell me now, 4 into 10 power 6, and this is how much now, LCM 4 pi R square, so will come it as 3 pi R square by 4. 4 will get cancelled, so this is I is equal to, so this is 3 pi into 10 power 6 into R square. R is radius given na, how much this value, 4 into 10 power minus 3 mm whole square, which will come to be a 3 pi into 10 power 6 into 16 into 10 power minus 6. So we can say plus 6 minus 6 will get cancelled. So then I value will come to be a 48 now. 48 pi. Okay. Next. Yeah, same thing here. This also. The current density in a cylindrical wire of radius R 4 mm is this one. J value given. So the J value current density which is given as 1 into 10 power 6 ampere per meter square. And they ask him to find the I. I is equal to J into area. Now tell me how much is area. So this is j value 10 power 6 into we have total area. This is pi r square minus pi r square by 4. Simplify, get it. So 10 power 6 into, so 3 pi r square by 4, which will come to be a 3 pi by 4 into 10 power 6, r value 4 into 10 power minus 3 whole square. So how much will come here? 3 pi by 4 into 10 power 6 into 16 into 10 power minus 6. Then plus 6 minus 6, 4 fourths. How much is value? 12 pi. 12 pi amperes. Next. An aluminum wire is stretched to make its length is 0.4. So if whenever the change of any parameter, if it is less than 5%, then directly we can do analysis. The resistance directly proportional to L squared now. Then we can write the delta R by R like a measurements concept. 2 into delta L by L. So then we can say now delta R by R into 100, which is equal to 2 into delta L by L into 100. So this is the percentage. 2 into this value less than 5%. Now we can apply this concept directly. This is, yes, so we'll directly we apply. This is 0.8%. Okay. Next one. The length of a given cylindrical wire is increased to double of its original length. The percentage increase in the resistance of the wire is. The length of a given cylindrical wire is increased to double of its original length. So this is L2 is equal to 2 times of L1 double. They are asking to increase it to double. It is stretched. So that means obviously a resistance proportional to L square na. Then we can say this as R2 by R1, which is equal to L2 by L1 ka whole square. Then it is R2 by R1, which is equal to L2 means 2L1 by L1 whole square. Yeah. Now simplify this thing. R2 by R1, which is equal to 2 square means 4. So that is R2 by R1, which is equal to 4. Then percentage R2 by R1 minus 1 into 100. So means what are we 4 minus 1 is a 3 into 100. This is delta R by R1 into 100. And which is equal to how much we can say now 300%. Okay. Next. For the circuit shown, the value of current at t is equal to 3.2 seconds is. They ask him to find the value of current at 3.2 seconds. So 3.2 seconds. Basically, the current is what, tell me now? Which is equal to this one, V minus 5 by R. R is 1. V value at t is equal to 3.2 seconds we need. 3.2 seconds means somewhere here na. Now if we see these points, now the coordinates, we need to get a straight line, right? This equation of the form y is equal to mx plus c form na. So here they given v of t. So v of t will come to be y is equal to mx. Mx means slope is how much now? 10 minus 5 by 4 minus 3. So it is 5e the slope na. 5t plus some c is a constant. Okay. Now I need to get the constant c. For this you take any point. Now I have taken this point. This point x coordinate is 3, y coordinate is 5. So we'll substitute these values now here. Y coordinate, which is equal to 5, is equal to 5 into x coordinate is 3 plus c. So that is 5 is equal to, we have this is 15 plus c na. So c value will come to be a what, tell me now? Minus 10. So finally we have v of t. So v of t, which will come to be a what, tell me now here? 5t minus 10. 5t minus 10. We need the voltage when t is equal to 3.2 na. Put this value v of t, which will come to be a 5 into 3.2 minus 10. How much this value? 15, 16. That is 6. So then I value will come to be a 6 minus 5 by 1, which is equal to 1 ampere. Two wires of same length and thickness having specific resistance 6 and 3 respectively are connected in parallel. They connected in parallel. The effective resistivity given as a rho. The value of rho is okay. Same length, same thickness are connected in parallel. Okay, what is the resistance of any material which is given as, we can say rho 1 into L by A. Okay. And the second one, resistance is what we can say now, rho 2 into L by A. Okay, when these two are connected in parallel, the effective value, what I can say now here, R effective, which will be equal to rho is a rho effective. Okay, rho effective. Length is same, area will be 2A na, A plus A. Connected in parallel. So basically when the two resistors connected in parallel, equivalent resistance is given by what, tell me now? 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2. So it will come to be a 2A by rho equivalent into L. This is A by rho 1 into L plus A by rho 2 into L. So now simplify now. So that is 2 by rho equivalent equal to what element of 1 by rho 1 plus 1 by rho 2. Okay, so then it will be 2 by rho equivalent, which will come to be a LCM. So this is rho 1 plus rho 2 by rho 1 into rho 2 na. Then from this rho equivalent, which is equal to 2 rho 1 rho 2 by rho 1 plus rho 2. So this is rho equivalent, which is equal to 2 into rho 1 is 6, rho 2 is a 3 by, so 9. Cancel it now here, 3 3s, 3 2s na. So this rho equivalent, which will come to be a 4 ohm into centimeter. Okay. Next. A current through a wire depends on time is given by. They given the current through the wire. So I is given as alpha. Alpha given as 20 t plus 8 into t square. They ask him to find the charge for 15 seconds. So that means charge is given as resistance nahi. This is the given. So these are ohm into centimeter, specific resistance. Resistivity, ohm into centimeter. So here specific resistance means resistivity. Specific resistance is nothing but resistivities. Resistivities, not resistance values. Resistance is different, specific resistance is different. And how to get the charge now? Integral of I into dt na. So simplify this thing, get the value. So then that is from the limits are 0 to 15, I that is 20t plus 8t square into dt. Now integrate now here. So 20t square by 2 plus 8t cube by 3. Limits are 0 to 15. You can substitute the limits now. So that is q is equal to finally 10t square plus what will be now 8 by 3 into t cube. Yes, limits are 0 to 15. How much will come? So this is 10 into 15 square means 225 plus 8 by 3 into 15 cube, that is 225 into 15 and 3 5s. Then Q value 2250 plus how much this value? This is so 8 5 40, 40 into 225, that is 9000. So then how much this value? Tell me now. 0 5 to 11. So this is 11,250 coulombs. Option B. Next one. Now see the next one. A wire of 1 ohm resistance has a length of 1 meter. It is stretched till its length increases by 25%. Length increase by 25%. You no need to consider the given length. Increased by, so simply I am considering L1 is equal to 100. And this is L2 increased by 25% means we can say 25. 125. So then, so resistance, how it is proportional to length now here? L square. So that means R1 by, I can write R2 by R1, which is equal to L2 by L1 ka whole square. So that is R2 by R1 minus 1, which is equal to L2, 125 by 100 whole square minus 1. Yeah, simplify this thing, how much will come? Now this is R2 minus R1 by R1 into 100, which is equal to, so 25 5s, 25 fourths na. So this value 25 by 16 minus 1 into 100. Tell me how much will come now here. 25 minus 16 by 16 into 100. So how much is value? 9. 9 by 16 into 100. So 9 by 16, 4 fourths, 4 25s. Now how much will come? 9 into 25 by 4. So we'll get this value. This is percentage of resistance. That is delta R by R1 into 100. Yeah, which is equal to 56%. Next one. The charge on a capacitor plate in a circuit as a function of time is shown in the figure. Figure as like this. What is the value of current at t is equal to 4 seconds? So that means charge given, how to get the current for capacitor? I is equal to C into, basically charge given directly, I is equal to, we can say now dq by dt only now for anything current ke liye. So at t is equal to 4 seconds, you see the charge remains constant. At t is equal to 4 seconds, q value constant na? If it is constant, so derivative will become 0. So that's why I value will becomes what will be now? 0. Next. The resistance of a wire is 5 ohms at 50 and 6 at 100. The resistance at 0 degrees is. That means they are asking to find the R0 value. The variation of resistance we know that is given as R0 into 1 plus alpha t. So they given this as a 5 equal to, this is R naught. R naught only we should get. Alpha we don't know. 1 plus alpha into 50. Next one, 6 equal to R naught into 1 plus 100t. If I take the ratio now here, 6 by 5, which will come to be a 1 plus 100t by 1 plus 50 alpha. So here this is 100 alpha. Yes, this is 100 alpha by 50 alpha. Right. Now we need to simplify now here. Cross multiply 6 plus this is 30, 300 alpha equal to 5 plus 400 alpha. We need to get 1 is equal to 200 alpha. That means alpha value how much? Alpha equal to 1 by 200. And we'll put this in the first equation. That is 5 equal to R naught into 1 plus alpha, that is 1 by 200 into 50. So, which is given as, so here 5 fourths now. So simplify it now. This is 5 is equal to, that is R naught into LCM. So this is 5 by 4. 5 cancel, so that is R naught equal to 4 ohms. Next one. An electric current is passed through a circuit containing two wires of same material connected in parallel. If their length and radius the ratio given, the ratio of the current passing through the wires is. Okay, so connected to same supply na, parallel they connected. So potential to same I. We need to get this value I. I is equal to what element of V by R. So you can see now here from this we can say I proportional to 1 by R. Now what it is, R is equal to rho L by A, that is R proportional to L by R square we can say. From this I can write I proportional to R square by L. Ulta na? Now we can find the relation now here. So this is I1 by I2, which is equal to R1 by R2 whole square L2 by L1. So then it is I1 by I2, which is equal to radius ratio. Radius ratio, this is 2 by 3 whole square. Length ratio 4 by 3 means 3 by 4. Will come it as 4 by 9 is to what tell me now, 3 by 4. So will come to be what tell me now, 1 by 3. Yes, option is there now. Yes. Next one. Tell me this thing. The equivalent resistance between A and B. Right. Yes. If I call this point is something C, this point is also C. This point is D. This point is also D only. Okay. Now we will redraw the circuit now here. I am taking this is A. Yes, this point is C. and this point is A, this point is C, this point is D, and this point is B. So from A to C, the resistance is given as how much now? So that is 6 ohms. Now this is C to D now, how much? 15. This is 15 ohms. And this is also C to D only. How much now? 15. And this is also C to D only. 15. And D to B, which is 8. Right. And you can see now here how these three are in parallel. So how much this value? This is the 5 now? 5. So from this we can say now equivalent resistance, you tell me now here. So that is RAB, which is equal to 6 plus 5 plus 8. How much this value? 11, 19. 19 ohms. Okay. Got it, all of you? Done. Fine. Okay, that's it for today's session. So next class will continue remaining problems. Okay. Okay then. See you. Bye bye. Take care.